Hello and welcome back to my YouTube page on math videos. I'm really excited about today's video, but I also have to acknowledge that it is the start of a brand new school year. And so while many of us are probably out there setting up our classrooms, or if you're a kid who's getting ready for school and kind of nervous, or if you're a parent who's wondering how am I going to get through another year of math, this is the page for you. I'll have new videos every Tuesday and Thursday, and please just go to the bottom in the comments and give some suggestions for videos you would like to see for help with your student or help for yourself or even help for your own classroom. So with that said, today's video is based on a viral challenge that came out on Twitter this summer. So let's jump right in. See you soon. So this is the problem that showed up on Twitter about a month ago. I explored it with a whole bunch of new teachers this summer, but it was really interesting to watch people just argue back and forth on this problem. So I'm just going to start by reading it left to right. 8 divided by 2, parentheses 2 plus 2 equals what? And my goal for today is to think, how do we take this problem and really try and dig in deep, not just to find an answer, but to really understand how this problem really works together. So going back to the original problem, we saw that most people were confused and really arguing back and forth because there were two possible answers to this depending on how you solved it. So I'm going to go back to it for a second. And this is what I'm going to ask you to do. Take out a paper, some pen or a pencil, and just take 30 seconds to solve this for yourself and see what answer you're coming up with. Just pause the video right now. Okay. So if you solved it, you probably saw that you were coming up with a 1 or a 16. More than likely, those are the two popular answers that you received, and you probably got one or the other. And again, why? Math is supposed to be this subject that has a definite answer. It's not subjective. It should be completely objective. And if everyone learns to do math the same way, their basic operations, why are we getting two answers? And go back to when you were in elementary school, or if you are in 4th grade, you're learning something called PEMDAS. And PEMDAS is just an acronym for order of operations, the sequence of steps we're supposed to use when we have a problem that has lots of operations. And here in America, we call it PEMDAS. In other areas of the world, they may use PEMDAS, but the premise is still the same. We have parentheses, exponential forms, multiplying, dividing, adding, or subtracting. And I remembered this when I was little by saying, please excuse my dear Aunt Sally. And convention when I was young was just to start from top to bottom with parentheses, simplifying anything in there first and going all the way down in these exact steps. However, convention now, one, we don't say PEMDAS, we say order of operations, is to follow these 4 steps. Of course, simplifying anything in parentheses, simplifying anything in exponential form to a single term, multiplying or dividing from left to right. That is a big difference from when I was younger, and adding or subtracting from left to right. And this does make sense because those two operations are inverse to each other, so it shouldn't really matter which direction I'm actually doing them. However, if I did them in a different direction, I come up with a very different answer. Okay, so why again are we getting two different answers? And really the answer is we're interpreting this problem very differently in the way we're looking at it and the way we're identifying the different operations. So for example, take a look at these two calculators, and they both seem to have very similar word problems, the one we've been showing. However, if you look really closely to the one on the left, you'll notice that the 8 divided by 2 is in fractional form, and with the one on the right, there is just a regular division symbol. But that's one main difference that can help maybe understand why we're interpreting this problem so differently. So what we're going to do, we're going to jump into this problem, and to be fair, I just think it is purposefully ambiguous. It's written in a way that can be interpreted in 2 different ways, and that's why we're getting 2 different answers. Okay, so I'm in my little notebook, and let's jump into this problem over here. And so I've written it out exactly as we've seen. And usually everyone will start the same way. They'll start with that parentheses and they'll simplify this into a 4. And we rewrite the rest of the problem as so. But this is where we can have 2 different pathways depending on how we interpret this problem. So I can see some people saying I'm going to follow order of operations. I don't see exponents, but I do see division. So I'm going to do that step next. And you'll get 4 times 4 to get an answer of 16. They're going to do their division first. And then I could also see this pathway where people will argue, although there is division, I have to do this 2 times 4 first because it's not written as 8 divided by 2 times 4. They're connected through a parenthesis, so these are really grouped together, and I really should distribute before I move forward. So I can see people doing 2 times 4 to get 8, rewriting the problem and getting 8 divided by 8 to get 1. And that's where this confusion comes in. Which way do we go? That parentheses changes so much, and we have to really ask ourselves, is it just multiplication written in this way? Or, because then I know which way I'm going to go. I'm going to go the path to the left. Or do I really have that grouping of 2 and 4? It's so important. I have to work on that. And so how are we going to rewrite this problem to make it less ambiguous? Because it makes total sense, these 2 pathways that people are going to get these answers of 6 and 1. So here's my suggestion to deal with this ambiguity. And the first way is, honestly, I would rewrite it using a fractional form. And the reason is, let's just think of it this way. If I did 8 divided by 2 times 2 plus 2. Okay. Still doesn't look like I know what I'm doing. It doesn't look any different. But what if I express it in this way? I can see 8 over 2. So I know they're together, and I know which operation I'm supposed to do first, which is really the parentheses 1, 4. But then I'm also going to simplify the 8 halves to get 4. Now I have 4 by 4 to get 16. Or am I looking at the problem written in this way? 8 being divided by this entire expression of 2 times 2 plus 2. See the difference in our denominator? And this is where the problem becomes so clear, crystal clear. Do I really want the 8 being divided by 2 and then being multiplied? Or do I want the 8 being divided by that entire expression, 2 times 2 plus 2? So when I do that, I'm starting off with this parentheses part. So I know I'm getting 2 times 4. So I have 8 over 2 times 4, which is 8 divided by 8, which gives me 1. So this right here, this one step, just changing it to a fractional form, is going to get rid of that ambiguity because it shows me which way the problem should be solved. My second tip is to just think about your brackets, your grouping. And that's why we start, when we say PEMDAS in other countries, they say PEMDAS because they think of their brackets. Because then this way, I can use my brackets and say, well, I really want to separate these 2 operations. So that's one interpretation. And that's kind of like going with this first example over here. So I can see how they're really connected. Or do I mean, I'm going to use a bracket here, that the 8 is being divided by that entire expression, the 2 times 2 plus 2. And now I can see in this second case that the 2 is being connected to here. So who is that 2 really connected to? Is it more in this first with 8 being divided by 2 and then this other operation, or is the 2 being connected to the sum of 2 plus 2? So that's one way we can get away from this ambiguous problem. And let's be honest, this is intentionally ambiguous. The whole purpose it was written this way was to create this discussion and this back and forth, because there are multiple ways that we can just talk about this problem. So it's very intentional. So, okay, let's say for some of us teachers, we're looking at this problem and our kids are coming in and asking, how do we do this? Because especially if you teach 5th and 6th grade and 7th, order of operations is so important. By 8th grade, they can use calculators, and it's still important into the way we're going into the calculator, but it's more emphasized in that 5th through 7th grade. So we know we are absolutely discussing this acronym, which can also be discussed as PEMDAS. Like I said, we can use either one. And the first tip I would have for teachers is there a real context to this? Why are we doing this type of problem? How is it even connected to the real world? Because that can tell us a lot. If I have 8 of something that's being cut in half and then distributed out, and I have multiple groups of it, then I know which way. Or do I have 8 of something and I'm equally sharing it in this other way? So is there some type of context to this that would help out? The other thing that you can do is to use this as an opportunity to really talk with your kids. And one way I do it is I have kids just pair up together, and I have one of them become the convincer and one the skeptic, and they both solve it, and one kid really goes into how they solved the problem and how they got their answer, and the second student is the skeptic and can ask them some questions and really push their thinking. And that's the big point. Can they push their thinking so that someone is convincing them that that is the answer? And then they can switch. And this changes this type of problem, teachers, because now it's not just about who's right and wrong. It's really about justifying your thinking. Can you discuss it? Can you take something that is just a procedure and push it in this other way so it's more meaningful? That's a richer conversation than I'm just right or wrong. It becomes a deeper problem. So I really hope you enjoyed this video and that you found it helpful. And here are some ways that you can continue to engage and have these conversations. New videos twice a week. But if you have additional questions, absolutely, you can email me at sarah@mathminilessons.com. And you can ask me all kinds of questions there, or you can just go right into the comments and ask different things. I would love to know people's thinking about how they solved this problem, what they were noticing, what they were thinking, and about my suggestions. I hope this was helpful. And for those of you starting the brand new school year, have a great school year. Thank you guys so much. See you in a few days.